Hello and welcome back to Advent of Code 2019. We're up to day 23. And of course it's an int code one again. Okay, let's begin. Category 6. The droids have finished repairing as much of the ship as they can. Their report indicates that this was a Category 6 disaster. Not because it was that bad, but because it destroyed the stockpile of Category 6 network cables as well as most of the ship's network infrastructure. You'll need to rebuild the network from scratch. The computers on the network are standard int code computers that communicate by sending packets to each other. There are 50 of them in total, each running a copy of the same NIC. That's the program. Okay. The computers have network addresses 0 through 49. When each computer boots up, it will request its network address via a single input instruction. Be sure to give each computer a unique network address. Single input instruction. So we have to give 0 or 1, depending on which... Okay, fine. So as input, we give the address of this computer. Why does it say request? We're telling... okay. Once a computer has received its network address... Oh no, the computer. We're giving the computer. It's receiving from us. Okay, that makes sense. It will begin doing work and communicating over the network by sending and receiving packets. All packets contain two values named X and Y. Packets sent to a computer are queued by the recipient and read in the order they are received. To send a packet to another computer, the NIC will use 3 output instructions that provide the destination address of the packet, followed by its X and Y values. For example, 3 output instructions that provide the values 10, 20, 30 would send a packet with 20, 30 to address 10. Okay, fine. We have a framework for doing this. To receive a packet from another computer, the NIC will use an input instruction. If the incoming packet queue is empty, provide -1. What? I don't understand this paragraph. If the incoming packet queue is empty, provide -1. Okay. Otherwise, provide the X value of the next packet. The computer will then use a second input instruction to receive the Y value for the same packet. Ah, okay. We're not... Okay, fine, yeah. This is how we're actually sending the packets. So we're told what to send here, but we actually do the sending by... by doing this. Okay. Note that these input and output instructions never block. Specifically, output instructions do not wait for the sent packet to be received. The computer might send multiple packets before receiving any. Similarly, input instructions do not wait for the packet to arrive. If no packet is waiting, input instructions should receive -1. But why would we ever provide -1? Surely we would only interact with a computer when it's received something? Or what? First packet sent to address 255. Oh, they don't have any example here. Why didn't they have an example? That would have made things a bit clearer, because it's a bit confusing. Okay, fine. So I think... it doesn't really matter what order we do things in. But does it matter? Okay, fine. Let's just try running these computers then. Okay. So we want 4 address in range 50. Just hang on. So we create a program. We want to input input the address of its program, and then compile that into a list. So we have a set of computers all initialized. Then what do? We read the output from one of them arbitrarily? So what happens when we get output? I forget how this works. So if we do get output, turn next self to automaton. So it's not going to interrupt the program. It's just going to return none if there's nothing in there. Huh? Okay. So should I just... So should we just go through the computers like this? So for... computer in computers. Out address. So they'll give us the address to send a message to. Equals computer dot get output. If out address is none, continue. So otherwise we have an instruction now. So x equals the next out. Oh, yeah, x equals the next one. And y is that. And then what? I don't understand this -1. Why would we ever input -1 to a computer? Surely we only input stuff once we have stuff. So if we've got this... Incoming packet queues empty, provide -1. When would that ever come up? Otherwise provide the x value of the next packet. And the y value. Why did they not give an example for this? This is one which sorely needs an example. Similarly, input instructions do not wait for a packet to arrive. If no packet is waiting, input instructions should receive -1. Should we always be giving -1 whenever we are requesting an output then? The computer might send multiple packets before receiving any. Oh. I think we always have to have -1 sitting on the input instruction if there isn't anything else. So when we do this, we look at the queue of inputs, and if there's nothing there, we just put -1. So if we want to look at the queue, self.queue equals queue. If computer.queue.empty, then computer.put input -1, and then we try and get an output. And if it had stuff on it, then we wouldn't need to do that. But does order matter here? Because I suppose they won't give an output until they've got the right stuff, so maybe this is fine. If out address is none, then they've got nothing to tell us, I think. Okay, fine. And if they do have something, then we want to so it would be computers out address dot put input just put X and Y. So that will be in the queue. Ugh, will this work? We have to do this endlessly. We might as well just break out of this for loop and start again from the beginning of the computers. So we're trying to find a computer that is ready to tell us something. And then what was the thing we actually want to find? What is the Y value of the first packet sent to address 255? Okay, so if out address is 255, well, let's do it here so that we can break out of this while loop. If out address address equals 255. Print whatever the last Y was and break out of this while loop. Yeah, well, out address, that's fine. Is it doing anything? Not doing anything. Out address equals computer.get output. So is any computer giving something? Oh, it's blocked. What? Oh, print something. It's blocked. But I've given -1. So, isn't that what I'm supposed to do? If the incoming packet queue is empty, provide -1. So we got to the first computer, address 0. It's been given the address 0. Ah. Ah, but there's no -1 to begin with. So should we always... We basically need the input to always be -1 if there's nothing in the queue. So we want... What we don't want put input here. We want to always have a -1 at the end. Or can we override something? Provide fixed input -1. But then the code, what does the code actually do with this fixed input? So if there's nothing on the queue, we take the fixed input. That's what we want. Is that the behavior that we've already coded? Equals self.fixed input if self.fixed input is not none, else self.q.get. But no, that's not quite what we want. We want it the other way around. We want... If there's something on the queue... Should I change this? This might break the behavior in previous questions. Oh, it doesn't matter. Say if... So it'll be self.fixed input if self.q.empty. So if the queue is empty, just take the fixed input. Otherwise, take the next thing on the queue. That's what we want. So we can set the... Provide fixed input -1. So if it ever wants an input and there's nothing on the queue, just provide -1. Okay, try that now. It's got a bunch of instructions. And then it hangs. It's always on the same program, the first program. So the first program saying, give these instructions. Why is it hanging now? That it should still be taking... Oh man. It's because it's blocking because of there's no output. How do we do... How do we check whether there's an output without blocking? Oh, this is so confusing. It's not like this. Try return next self to automaton else. Yeah, but this doesn't work if it's... So it's this bit here. but there's nothing to yield, so it's just... Well, no, there has to be something to yield if it gets there, but... I don't understand. So it sent out all its messages. Do we actually want to use threading here? Because it's currently blocked, because it's waiting for... Is there a way around this? We have a way of knowing that there's no output. It's just waiting for an output, isn't it? I thought this would be none, but it's just hanging. We can use multi-processing. It's kind of... I wouldn't expect to have to do this, but... We shouldn't have to, though. You shouldn't need threading to solve this. Could be interesting, though. Didn't I have this issue before, though? How do you... Is that actually... So what happens here? We provide an input -1, and it's got nothing to give us. So this... This hangs. Until an input appears. No, it has an input. It just doesn't have anything to give us. I'm not sure how to do this then. I don't like this while true for computers thing. That's a bit weird. Maybe we do need multiprocessing. That's a bit... like, a lot of languages it's not easy to do that at all. I don't see any other way though. Because how... is there actually a way to know when a computer has run out of stuff to give us? Okay, fine. Let's look into multiprocessing. I don't know how to do this. So we need to define the function that each process will do. So we've got the computers, we keep that. Then we define proc. So the only output it will ever give us is these three ints. Hang on, so if a given computer we just basically do what's down here. So we say, oh, we don't need that anymore, do we? Wait, that wasn't affecting it, was it? No. Okay, so we say, so if there's, so we wait for an output, and if there is an output, then it will be an out address. So it's always going to be... Oh, I see. Well, okay. And then... should we print? No, don't do that for now. We do that, we do that. We just do that in a loop. But the process for a given computer is do that infinitely. Wait for an output. No, but this doesn't make sense because... What is it actually waiting for? An input? But there is an input. It's -1. So is it just repeatedly checking the input in an infinite loop? Is that what's going on? And the moment we put something that's not -1, it will give us something. Maybe. Okay, fine. If out address is 255, print goal, the y value. And now we need to figure out how to so we want or computer in computers P equals process target equals proc args equals the computer. P dot start, P dot join. Is that what we do? I don't know. Cannot pickle thread dot lock object. Oh, is this one of these global lock things? I just never understood this. Cannot pickle. From multiprocessing input queue. It's because of the queue we're using. Is it? Cannot pickle generator object. I don't know how to do any of this. Oh my god. The generator is not multiprocess safe, I guess. I thought this was going to be an easy one. Well, it had a good success rate. Well, no. It had a good part 2 rate if people solved part 1. Didn't necessarily have a good success rate. So if I could do part 1, then part 2 is probably easy. But part 1 is actually quite hard on its own. Cannot pick or generate an object. Well, I don't see any way around that. I mean, this whole int code thing is based on... Don't use a generator expression when you want to pickle data. Use a list comprehension instead, or call list on the generator to capture all generated elements for pickling. I don't know. So the problem is this... is the fact that I'm using yield. So do we want this? Self dot out equals list. And here we say self.out.append that. So there's no yield statements anymore. And then get output would be if self dot out return self dot out dot pop the first element, else return none. If we do that, is that just eliminating the blocking nature? Can we just now just run what we had before without the processes? No fixed input. Int code object has no attribute fixed input. What? No, because this now doesn't... We still want this to yield. But we're taking from out instead of the yield. I don't know. Doesn't do anything. I don't understand. Why does it even finish? It's supposed to go on forever. Why doesn't it print anything? What? Oh, it's actually doing stuff now. Okay, stop printing stuff. This could actually be working, I don't know. Let's just let it run for a while. So every time there's nothing to output, they output none. So should we actually break here? I don't know. Take out the break. Wait, we're not getting any out addresses. So everything's none. If self.out has something, this doesn't work, whatever I've done here. Also, this shouldn't be a list, this should be a queue. Alright, undo that. Self.out. Put that. Right, so we've got an out queue, and an in queue instead of whatever we had before. But this just does a single pass now. It's not even a... It doesn't wait for inputs. Because we're not doing next. So we should be doing... I don't know. If we're not calling next, then it's not doing anything, so this doesn't really work. We start the program, but if I just put next here, it's not gonna do anything. Let's go back to what I originally had, because this is a bit of a mess now. So I want to actually see... Okay, so we do get these outputs. That's something. Why don't we get the other ones? How do I get those outputs again? The break here? Yeah. Okay, so the problem we have is that this blocks because... It's waiting for an input other than -1, but it's never going to get it because we're blocking waiting for this. So confusing. I think having a queue, an out queue, maybe is the correct approach here. But we still have blocking behavior when we're telling it to put an output. But... what if I just don't try here? We just do this. It's the same thing. I don't know. We need to redesign our ink code now. This is... I don't like anything involving like parallelization and stuff. I think you do actually need multiprocessing here, because how could you possibly... Because you never know which computer's ready to give the instruction. You might give out a bunch of bunch of packets, but that doesn't mean those computers are ready to give their own packet. Like, they might be waiting for, say, I don't know, 3 packets before they give something. So just because I've given something to 31 doesn't mean that 31's now ready. The only way to solve this is concurrency. Run all these things in parallel. So they wait for the app. I just need to get that to work. Should I look up a hint on the Reddit? This maybe it'll give me some insight into whether I should be using multiprocessing or not. I don't see any way around it. Doesn't. $2015. No, it's 2019. Day 23. Yeah, it looks like you do need threads. Threading.lock to prevent race conditions. Oh god, I hate all this stuff. Only yield... Okay, somebody said... Only... my encode computer only yielded when it had output to return, so I had to add yield none after every non-output operation. Is that a hack for solving this? Yield none after every non-output operation. What does that mean exactly? I'm glad he's not doing problems like these anymore. Like, I don't like multi-processing stuff. I just find it boring. What was stopping me from using multiprocessing? It's the yield thing. I don't understand the can't pickle generator something lock something. I'm looking at someone's ink code. So he's put yield none after every opcode is read. That's interesting. Will that fix the issue? Let's try it. So we have to put yield none. Try that. Damn it, because that's going to interrupt the... Let's try this. X equals computer.get output while X is none. Okay, just that's such a hack, but whatever. List out of range. Int out address. Put what? Computers int out address. Put index. Oh. Let's put this here because I think we might have found the 255. There we go. Is that right? Must be. So this works, but I don't think it's completely safe though. I think it's just lucky that we have enough nuns to buffer it. But I think you could still run out of instructions. You really, the correct solution probably needs proper threading, which I just don't know. And it's not great in Python anyway. Python's not exactly a threading language. You got... Okay, that's correct. Packets sent to address 255 are handled by a device called a NAT, not always transmitting. The NAT is responsible for managing power consumption of the network by blocking certain packets and watching for idle periods in the computers. If a packet would be sent to address 255, the NAT receives it instead. The NAT remembers only the last packet it receives. That is, the data in each packet it receives overwrites the NAT's packet memory with new packets' X and Y values. The NAT also monitors all computers on the network. If all computers have empty incoming packet queues and are continuously trying to receive packets without sending packets, the network is considered idle. Once the network is idle, the NAT sends only the last packet it received to address 0. This will cause computers on the network to resume activity. In this way, the NAT can throttle power consumption of the network. So when the NAT sees that all computers are idle, it sends that last packet to address 0. Which will trigger another set of operations. I need to write proper threading now. I don't think this will work. How do we work out if the computers are idle? So nat equals none, none. We want to replace this with the x and y. So if this is 255, then we do nat equals x, y, like that. Okay, so that stores the nat. And we're saying if all the computers are idle, does that mean if we print that as well? I don't know. And now it seems to be idle, so... I reckon what we do is if computer and computers, so if all of these are none, that means we reach the else for this for loop. Then we do computers. Oh, whoops, I've got the browser. Computers 0 dot put input nat, the first nat and the second nat. I don't know if this will work. I'm just messing around now. None type an int. So that should be... So else means nobody had anything to do. Oh, it doesn't necessarily mean it's idle. So we need some sort of, should we say if we've, I don't know, idle counter equals 0. Alright, so if we do something ever, then idle counter resets, okay? So if, otherwise, okay, idle counter resets now, right? So if we go through all the computers, nobody had anything to provide, then idle counter plus equal 1. If idle counter is greater or equal to, I don't know, 100, we can set this number. This is not a very good solution, but we're just trying to find the right number. So that if it's gone through the loop that many times without any changes, then we'll say it's idle. Because I can't be bothered to work out a proper multiprocessing solution. So if I do that, so I don't know, 1,000. So now, what happened? I think it did it twice in a row. What is the first Y value delivered by the NAT to the computer address 0 twice in a row? I think it's 10738. I want the... Oh no, there's lots. We need to... No, but we're looking for the NATs. Is it 1037? 738? Okay, but I mean, we could do this programmatically, check what the last value was, but... Correct. Alright, so that idle counter, it was a hack. It doesn't 100% check that everything's idle, because we can. There is a way to work out if everything's idle. Just can't be bothered to work out how to implement it. This works. I hate it. I guess I'll watch a video of someone solving this the proper way, because I need to learn this stuff eventually, but it's... Then again, Python's not really the language you would do it in anyway if you were going to do multiprocessing. Multiprocessing is not technically parallelization, but whatever. Okay. But we hacked it. But I might want to leave my program the way it was. So... How was it? We'll leave the input value the way that seems sensible, but everything else will put it back the way it was. Yeah, 23 won't work anymore, but... Wait, what was the answer to the... No, yeah. Okay. I mean, it's an interesting thing, it's just not my cup of tea. I don't care about parallel programming. I mean, because I was a theoretical computer scientist, and theoretical computer scientists don't like parallelization because it's not actually speeding up anything, algorithmically speaking, it's just doing stuff in parallel, so multiplying by constant factor. That constant factor being the number of computers. So, like, at the Turing machine level, if you only care about what's actually happening in terms of basic primitive operations, parallelization technically does nothing. In practice, obviously, it's a very useful thing, and like you need it to accomplish a lot of things. But at the theory level, it's just boring to us mathematicians because it's not algorithmically improving anything. It's just speeding stuff up. But yeah, okay. So that's 23 done. Should take a sneak peek at 24. Land on Eris. Oh, it's a game of life type thing. These are usually not that hard. Powers of 2. First layout that appears twice. Interesting. It might just be a straightforward simulation. I don't think there's any clever number theory you need to use here or anything. We'll see. First layout that appears twice. How would you... Is it an infinite grid? No. So you could just hash the grid? Dunno. Find out next time. Find out of Discord. Oh, I've got the wrong window being shown as well. Keep doing that. Alright. That's enough of that. See you maybe tomorrow or the day after. Bye-bye.